So we're going to look at example number 4. This is the one we did not do in class first. This is a red ball, a 1.2 kilogram red ball moving at 10 meters per second. It strikes a 2.31 kilogram blue ball moving at 15 meters per second. If the final velocity of the red ball is 3.5 meters per second, determine the final velocity of the blue ball, and we're to use the angles in the diagram below. So let's start. And we're going to start with the red ball. So notice I can draw my vector components here. This is the momentum of the red ball in the x direction initially, and this is the momentum of the red ball in the y direction initially. And we need to calculate the actual momentum, and that's 1.2 times 10. So the momentum of the red ball is equal to 12 kilograms times meters per second. That's just the magnitude. We use that to calculate and I did the x and the y backwards. This is the y direction here, and this is the x. Okay, let me just clean that up. So if we're going to calculate the initial momentum in the let's do x direction first for the red ball. And I'm just going to keep all of the red in red ink and all of the blue in blue ink, and that'll help us distinguish them. We take the initial momentum of the red ball and we multiply it by the x is adjacent, so that's the cosine of the angle of 30 degrees. So that's 12 times the cosine of 30 degrees, and that gives us 10.392 kilograms times meters per second to the right. And if we calculate the y direction for the red ball, that is the initial velocity times the sine. Just let me clean that up. For some reason, I'm not changing. There we go. Times the sine of 30 degrees, that's equal to 12 times 30 degrees, and that gives us 6.00 kilograms times meters per second, and that's down. Remember, this is all before in the red direction. If we can do the before for the blue ball, and notice it has y direction initially going up, and it has x direction initially going to the right. So we get our initial velocity, our initial momentum for the blue ball is 3.21 meters or kilograms times 15 meters per second, and that gives us 34.65 kilometers times meters per second. If we times the momentum in the x direction initially, that's going to be again adjacent, so it's equal to 34.65 times the cosine of 40 degrees, and that gives us 26.544 kilograms times meters per second to the right. Then if we do the blue ball in the y direction, we take 34.65 times the cosine of 40 degrees, and that gives us 22.275 kilometers times meters per second upwards. The next place where we need to do vectors is after. So the red direction after. Let me make that red. So we've got P for the red in the x direction final, and the momentum in the y direction final, and it's at an angle of 25 degrees. So after for the red, we need to find the magnitude of the vector after, and that's its mass of 1.2 kilograms times 13.5 meters per second, and that gives us 16.2 kilograms times meters per second. So to find the final velocity for the red ball in the x direction, we take 16.2, the momentum, multiply it by the cosine of 25 degrees. That gives us 14.682 kilograms times meters per second. Right. And then we do the y direction, the momentum in the y direction. We take and multiply 16.2 times the sine of 25 degrees, and that gives us 6.8464 kilograms times meters per second, and that is going up. So right is positive, up is positive, down is negative. So at this point, we need to start looking at the sum of the vectors in the x and the y direction. So I'm going to take and put that over here. So we know the sum of the momentum initially in the x direction is equal to the sum of the momentum in the x direction finally, or the final momentum. So I take the red in the x direction, so that's 10.2392 plus the blue in the x direction, which was 26.544, and that equals the sum in the x direction final, and that is 14.628 plus the momentum for the blue ball in the x direction final, and I'm just putting it in blue. Maybe I'll put the subscript there. So we add those together. We add the 10 and the 26, and we subtract the 14. That brings us with the sum of the momentum for the blue ball in the x direction final to be 9.4286 kilograms times meters per second. It's positive, so it's to the right. Now we're going to do the sum of the momentum in the y direction initial plus the sum of the momentum in the x direction. Sorry, in the y direction. Final. Again, we take the momentum in the y direction, initially for the x, which was 6.00. We add to it the momentum for the blue ball, and notice for the blue ball, oh sorry, that one was down, not up. So it's negative because it's acting downwards. The blue is positive because it's acting up, and it was 22.275, and that's equal to the momentum, the final momentum of the red ball in the y direction, and that's 6.842464 plus the final momentum for the blue ball in the y direction. So again, we add those together and subtract, and I've made a mistake. So I'm just going to correct my mistake right now. This momentum, the momentum for the blue ball, the final momentum for the blue ball in the y direction is equal to the amount of 9.4286 kilograms times meters per second up. And this is incorrect. Oh, hold on. That was correct. It was this piece that was incorrect. I picked up the wrong number. I picked up the y instead of the x. And so this needs to be corrected to 22.254 kilograms times meters per second. Right. And I apologize for that mistake. I hope you haven't spent a whole lot of time there. Okay. Now that we have the momentum in the x and the y direction for the ball after, we can draw the vector and see what's happening. And so we notice that it's to the right, so this piece here is going to be the resultant. And it's 22.254 kilograms times meters per second to the right. And interestingly, the diagram shows it's going down, but it ends up going, the blue ball ends up going up, and its momentum in that upward direction is 9.4286. So our resultant runs across here, our resultant momentum. Let's just make that the momentum for the blue ball. Final. So we calculate the momentum for the blue ball final, or the final momentum for the blue ball. That's using Pythagorean theorem. It's 22.254 squared plus 9.4286 squared, and that gives us a magnitude of 24.169 kilograms times meters per second. To get our angle here going up, we use again the inverse tangent as we've been using before. We use the opposite, which is 9.4286. divided by 22.254. That gives us an angle of 22.96 degrees. Now, remember that we're not being asked for the velocity, or for the momentum, we're being asked for the velocity. So we've got our momentum, now we can find our velocity. The momentum divided by the mass gives us our velocity, so we take 24.169 divided by the mass, which was 2.31, and that gives us a velocity of 10.46 meters per second. So our final velocity for the blue ball, I guess I should say those backward, I have that written backwards. The final velocity for the blue ball is, and it's all to 2 significant digits, so we have 10 meters per second, 23 degrees, and it's going upwards, so that would be above the horizontal. And that is the resultant velocity for the blue ball.